All right, so we're continuing now with our Chapter 6 practice test. We're going to look at questions 4, 5, and 6. So let's hit it over there. We have this table of values, and we're supposed to approximate the area between the x-axis and f of x for x between 0 and 4. Hopefully by now you realize that this is just asking you for the integral of f of x between 0 and 4. Because that's going to be the area between the axis and a function f of x, provided that f of x is above the x-axis, which it looks like this function is. So a right rectangular approximation, I usually tell you all to put this in a table. 0 to 0.5. Let's organize this. This is x intervals. Next interval, 0.5 to 1. Next interval, 1 to 3.5. And last interval, 3.5 to 4. Okay. Next, what is the delta x for all of these? 0 to 0.5, that has a delta x of 0.5. 0.5 to 1, that has a delta x of 0.5. 1 to 3.5, that has a delta x of 2.5. And then 3.5 to 4, that's a delta x of 0.5. Notice how craftily this is, so you can't use a formula. You have to find the area of each individual rectangle. Okay, lastly, this does say a right rectangular approximation, so we're going to do f of x on the right side. So let's highlight all the right sides. That's at 0.5 on the first interval, 1 on the second interval, 3.5 on the third interval, and 4 on the last interval. So this first one was, what is f of 0.5? And that is 2. Next interval, what is f of 1? F of 1 is also 2. Next interval, what is f of 3.5? Well, f of 3.5 is 8. And what is f of 4? Well, it's 5. So this is enough information for me to go ahead and write out my integral. So the integral from 0 to 4 of f of x dx, that's going to be approximately equal to, and I always encourage you to write out the sum of products. So this is 0.5 multiplied by 2 plus 0.5 multiplied by another 2 plus 2.5 multiplied by 8 plus 0.5 multiplied by 5. Now this is supposed to be a no calculator portion, so all of these should be something that you can multiply really quickly. So 2 times 0.5 is 1. That's another 1. 2.5 times 8, so what is that, 12? 2 times 8, no it's not. 2 times 8 is 16. Half of 8 is 4. So 16 plus 4 is 20. 5 times 5 is 25, so this is 2.5. And now we can just add that together. So the integral from 0 to 4 of f of x dx can be approximated by 24.5. 24.5. All right. Provided that none of my arithmetic is faulty, which I don't always have the cleanest arithmetic. Okay, number 5, a little trickier. We are going to make a table again, but we're supposed to use a trapezoidal rule with n equals 4. Okay, so I think we're going to have to evaluate this integral in a bunch of different places. First of all, where do I need to evaluate this integral? Well, if I want to do, how many intervals? If I want to do 4 intervals, and I'm going from 0 to 7, then the interval with my delta x, That's going to be 7 minus 0 divided by 4, which is 1.75. Okay, so let's make our table here then. What do we got? We've got, no, we should make a table of values is what we should do first. So first one is we're going to put x. So my x's that I have to evaluate are at 0, 1.75, 2.5, yeah, 2.5, 3.5. My next one is going to be 3.5 plus 1.75, that's 4, 5.25. And then lastly, 5.25 plus 1.75 is 7. So we're going to have to evaluate f of x in all of those places. Now, I know I said that this is not supposed to be a calculator, a calculator question. So we should be able to evaluate all of these, but I'm going to do those really quickly. So we get these results, 0, -1, -9.1875. Now I admit to you, those aren't probably the most desirable results that you can get with an actual non-calculator question. Probably would take it a little bit more easy on you with those numbers. So regardless, we can still use a trapezoidal rule, and let's figure out how that works. So in a trapezoidal rule, we're going to, of course, start with our intervals. So my first interval is 0 to 1.75. My next interval is at 1.75. Oh, you know what? I just realized something looking at this problem. My delta x is always 1.75. So that actually gives me the opportunity to use the trapezoidal formula. So in the trapezoidal formula, we can integrate from 0 to 7 of this function, x squared minus 7x. That's going to be equal to 1/2 delta x. And this is going to be f of 0 plus 2 times f of 1.75 plus 2 times f of 3.5 plus 2 times f of 5.25 plus f of 7. Okay, so again, that's the trapezoidal formula. We've talked about what the main distinctions are and how to memorize it. Next thing you're going to do is, now that you have your tables of value, you can just substitute all of those values. Delta x is 1.75. F of 0 is 0. F of 1.75 is negative 9.1875. Plus 2 times f of 3.5, which was negative 12.25, plus 2 times f of 5.25, which is negative 9.1825. I'm just reading it from the chart. Plus f of 7, which is 0. And now all you have to do is calculate this. These should be all approximately equal signs. And I get myself a 53.57625. Okay, I'm going to admit I used a calculator to do this. These numbers are kind of not nice. These are not the kind of calculations that I would expect you to make without a calculator. Maybe some other teacher would, but definitely not. Definitely I wouldn't. So just expect the numbers to be nicer if you see a trapezoidal rule, such as this one. So one more problem to go in this video is the average value of f of x. is equal to sine x. So before we do this, let's find the antiderivative of sine x. And to do that, we'll start with a derivative. So the derivative of cosine x is equal to negative of sine x, which is not good because we don't want the integral of negative sine x. We want the integral of positive sine x. So in order to find out the antiderivative of positive sine x, we'll just multiply everything by -1, and we'll get this, sine x. So if the derivative of negative cosine is sine, that means the antiderivative of sine is negative cosine x plus constant. Most of you are probably going to have that memorized if you don't have that already. You definitely should have that memorized. I would make that a priority. But seeing as we're just kind of learning here, I'm okay taking a couple of minutes talking about it. Okay, so if I want to find an average value, the average of anything in calculus is 1 over b minus a, the integral from a to b of f of x dx. That's the average of anything in calculus. Let's substitute the things we know. We know we're going to go from pi over 4 to pi over 2. F of x is sine x dx. Let's simplify this over here. Pi halves minus pi fourths is pi over 4. 1 over pi over 4 is 4 over pi. So that gives me a 4 over pi. The antiderivative of sine is negative cosine. And we're going from pi over 4 to pi over 2. Now we just need to substitute. So 4 over pi, negative cosine of pi over 2, minus 4 over pi, negative cosine of pi over 4. So now this turns into a little bit of a trig problem. 4 over pi, and the cosine of negative pi over 2, the cosine of pi over 2 is 0. So that's going to zero out. Minus 4 over pi. Now the cosine of pi over 4 is root 2 over 2. So negative root 2 over 2. This term is 0. This term, if I multiply that, I get 4 root 2 over 2 pi. Which simplifies, of course, into 2 root 2 over pi. So that is my average value, average. So that's it, everyone, for this part of our practice test. We've gone through numbers 1 through 6 now. Well, maybe this video is just 4 through 6, but I've done 1 through 6 already in this just one sitting. I'll see you next time for more calculus and your chapter 6 practice test.